Okay, folks, let's continue with our final exam review. This is part 2. I'm going to start with problem number 15. Alright, so in 15 we're asked to divide. Okay, now when you divide fractions, I know you know the rule from way back a long time ago. When you divide fractions, you take your original fraction and you flip the second fraction upside down and multiply. So we're going to do that. But also, we want to be able to cancel common factors. Well, the problem is that there's not factors going on right here. It's addition and subtraction. This is in just multiplied out form. So, also, I'm going to factor, I'm just trying to circle it, this numerator. And I'm going to factor this denominator, and I'm going to flip the second fraction upside down so we can multiply. Okay, and actually we're not going to do any multiplying, we're just going to cancel. So multiplies to be negative 10 and adds to be negative 3. Why am I doing that? Because this is a trinomial. It has a leading coefficient of 1, so it's one of those easier problems where you just write the two sets of parentheses and find the numbers that multiply to be negative 10 or the constant and add to be negative 3 or the x coefficient. And we know that's a negative 7 and a positive, that's wrong. It's a negative 5 and a positive 2, right? Multiplies to be negative 10, adds to be negative 3. So that's x minus 5 times x plus 2. Check me. Negative 5 times 2 is negative 10. Yes. Negative 5 plus 2 adds to negative 3. Yes. Okay? Let's do the same thing in the denominator. Check it out. There's a leading coefficient of 1. Therefore, I can do the same steps. I'm trying to find numbers that multiply to be negative 3 and also add to be the middle coefficient, negative 2. What numbers do that? A negative 3 and a positive 1. Remember, we're supposed to flip our second fraction. Hold on. Sorry about the disruption, but I'm back. Okay, so I've got to flip this x plus 2 over x minus 3. Now the x minus 3 is going to be in the numerator, and the x plus 2 is going to be in the denominator. And we start canceling. Notice I got an x minus 3 in the numerator and denominator, so those will cancel. I've got an x plus 2 in the numerator and denominator, so those will cancel. Now, if you ever have the same factors both in the numerator and both in the denominator, they won't cancel. It has to be numerator, denominator, just like these x plus 2, x plus 2, x minus 3, x minus 3. So I'm left with just x minus 5. Divided by x plus 1. Notice there really was actually no division that we did at all. We factored and we canceled common factors. Just remembering for a division problem, you must flip the fraction that's after the division sign. Alright, next problem, number 16. You've got x plus 1 over x minus 2, and we're adding to 5 over x minus 3. Now, listen, when you add fractions, y'all know you cannot add fractions unless you have a common denominator. And these are not common. So just like if you were to add 1/3 plus 2/5, you would have to find a common denominator 15. To do that, you'd multiply by 3 over 3 over here and 5 over 5 over here. That's what we're going to have to do to this problem too. Not 3 over 3 and 5 over 5, but you see what I'm saying. Common denominator here is just going to be x minus 2 times x minus 3. So I have to multiply this second fraction by x minus 2 over x minus 2, and this first fraction by x minus 3 over x minus 3. Okay? Just like you were doing regular old numbers. But it's kind of uglier when you're dealing with polynomials. So this denominator, the common denominator, is x minus 3 times x minus 2. You do not have to multiply that out. But now what we got going on up here, this, you do have to multiply out, okay? And when you multiply x minus 3 times x plus 1, you gotta FOIL it. So x times x is x squared. X times 1 is x. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. And you know what? I'm going to have to do a similar thing here, but it's not nearly as bad because I'm just distributing the 5. So 5 times x is plus 5x, and 5 times negative 2 is minus 10. What do I do now? I add like terms up here in the numerator, and then I factor. But one thing at a time, let's add like terms. So I've got an x squared. We've got an x and a minus 3x. That's minus 2x. Plus 5x, that's plus 3x, right? So positive 1 minus 3 is negative 2 plus 5 is 3. I've also got these two like terms. Negative 3 and minus 10 is negative 13 over x minus 3 times x minus 2. Now the next step would be to factor. Now there are no numbers that multiply to be negative 13 and add to be 3. So this would be the final answer, provided I didn't make any silly mistakes. I'm trying to scan over it, and I don't see any silly mistakes. That doesn't mean they're not there. I think we're okay, right? But again, if this numerator factored and one of the factors was an x minus 3 or x minus 2, we would have to do that and cancel common factors. And here we have a subtraction problem, and it doesn't have to have those directions that say subtract. We see that it's a subtraction problem. Again, it's very important that we have a common denominator, but look at us. We do. So these are much easier if those denominators match. Remember, this only matters if you're adding or subtracting. When you're multiplying or dividing, you don't have to have common denominators. What you have to do is factor. These we're not focused on factoring. We're focused on building a common denominator, and in this case, we already have it. So now what? Well, let me tell you what. This problem would be missed a lot because of the minus sign right there. Now, what do we do with that? We have to distribute into this numerator. That's going to give me 4 minus 2x. That usually goes pretty well for people. It's the minus 8 that causes people trouble. Over that common x minus 2, y'all don't dare add that stuff or subtract that stuff in the denominator. You just keep the common denominator. Now, that gives me a negative 2x in the numerator. And when I add my 4 and my minus 8, I get minus 4 over x plus 2. Now, if you circle that and move on, you're almost right. Almost. But not right. Why? Because there's a negative 2 that factors out of that numerator. Remember, you have to simplify if possible, which means you have to be able to factor. That's why we learned that factoring section, and there are other reasons too. But this x plus 2 cancels with this one, and my final answer is just little old negative 2, and that's it. All right, what are we going to do with this mess? It just says simplify. Well, y'all, this is called a complex fraction. We have a fraction, this guy right here, trying to circle in the numerator, divided by another fraction, the denominator. This is no different than x plus 2 divided by x squared divided by x minus 1 over 4x. Well, from the last problem, you know what to do. You need to flip that guy. Even if it's in this form, you always flip the denominator. But whenever you have that denominator needs to be a single fraction. Like if you were adding or subtracting down here, I don't mean just in the numerator, I mean two separate fractions. We would have to find a common denominator, combine those together, then flip. Okay, so here we go. We've got x plus 2 over x squared. I'm ready to flip. 4x over x minus 1. Now I can cancel common factors, and all they are is one of these x's right here cancels with that x right there. That's the only thing that I can cancel. Is that all right? Well, of course. So that's going to give me 4 from here times x plus 2 divided by x minus 1. Is that okay for an answer? It is. In my labs, we have noticed that they like you to multiply those out. But really, both of these answers are acceptable. Okay, so notice I distributed here to get that one. My labs math really likes to do that a lot, but there's nothing wrong with leaving the problem factored either. Now here I'm trying to solve an equation. I'm trying to find out what x's could possibly make this equation true. The trick for this is what's called clearing fractions. So we need to find a common denominator for every fraction involved here. That includes left and right side fractions. Well, don't want to find a common denominator until I know what this is factored. So really our first step in this problem is to factor. Multiplies to be 2, adds to be negative 3. We know that's a minus 2 times a minus 1 in parentheses. Aha, that's helpful. That's what we have over here too. So our common denominator is that, x minus 2 times x minus 1. Now what am I going to do with that? I'm going to multiply this entire equation, both sides, by that common denominator, x minus 2 times x minus 1. Why? Because that's what clears fractions. Now when you multiply the left side by that, you're really multiplying this fraction by that and this fraction by that. So I'm going to, in gross detail here, write all that down. So that's going to be times 3 over x minus 2. Then I'm going to multiply, well, we have a plus from here. another x minus 2 times x minus 1 times 1 over x minus 1. And then on the other side, I have 7 over x minus 2 times x minus 1. That was my original problem, times this x minus 2 times x minus 1. I'm multiplying that by all of them. Now, why did I do that? Well, that cancels with that one. And then we're just left with 3 times x minus 1 plus this x minus 1 cancels with that x minus 1. And we're left with 1 times x minus 2. Notice I'm writing this in a different order down here. Is that okay? Well, sure it is, right? And then on the other side, this x minus 2 cancels with that one. This x minus 1 cancels with that one. And we just have a little of 7. Hey, this is a little easier to stomach, right? Not so much fractions. And really, we need to be able to have our x's in the numerator to solve. We can't solve when x's are in the denominator. So what now? Distribute. That's 3x minus 3 plus distribute. X minus 2 is equal to 7. Then next, what do? I add like terms. 4x minus 5 equals 7. Y'all, this is a two-step equation. You're supposed to add 5 to both sides, right? It gives me 4x is equal to 12, and then divide both sides by 4, and that gives me x is equal to 3. Here's the deal, though. You must check these, okay? Anytime you have an equation that you're trying to solve and the variable lives in the denominator, you've got to clear fractions. And you might get what's called extraneous solutions. Those are solutions that are valid from your work. All your work is right, but they don't check. Now, what are you looking for? You're looking that when you plug this 3 into your equation up here, it doesn't give you a 0 in the denominator. Well, if I plug in 3 right here, it's going to give me a 1 in the denominator. Is that okay? Plug in 3 right here, that gives me a 2 in the denominator. That's perfectly okay also. And I plug in 3 here in the factored form, you see it's not going to give me 0. Now, you can go through the whole process and check that all of that is equivalent on both sides. But what I'm really looking is to make sure 3 is not undefined when I plug this in. So we're okay. Although if I was doing this on the test, you better believe I would check it all the way through. But I'm short on time, so we're going to keep cruising. All right, next problem. Not everybody's favorite. There is a video for all the word problems that show up on this test. This one kind of snuck into this review. But please, please, please watch and do the word problems for this test. It will hurt you if you don't go over that. And if you do go over it, then you'll be just fine on every single word problem on this final exam. So please do that. Now, we have similar triangles, it tells us. It says the lengths of the two sides of each triangle are given in the figure. Find the length of A. Okay? All right, so we've got to compare sides. Remember, this looks to be our 90-degree angle. So those are the same, which means Y, this Y is similar to this side right here. Okay? And this A is similar to this side right here, which also means this 5 is similar to this one right here. Now what we can do is we could work with just the small triangle and say side 5 over side A on the other side is equivalent to. Now if I put the diagonal 5 on top and the base A on the bottom, then I still have to put the diagonal 36 on top and the base 12 on the bottom. And then I have what's called a proportion. And to solve proportions, you cross multiply. So 5 times 12 is 60. You keep that equal sign in between, and 36 times A is 36A. I'm solving for A, so I divide both sides by 36. All right, and then I reduce that fraction to lowest terms. Now, what number goes into both 60 and 36? Well, 6, right? That gives us 10 over 6, but what else? 12. I could have gone bigger, or 2 down here. So 5/3 is my A value. Notice it didn't ask for Y, so I didn't calculate Y. It only wants A. Next problem, we get to simplify radicals. And when you simplify radicals, first of all, you got to look at what your radical is. This is the square root. So I'm trying to write 75 down into some perfect square times some other number. And the biggest perfect square would be helpful. So you think about things that multiply to give you 75, and one of them's got to be a perfect square. If you need to, make a list of perfect squares, either in your mind or on paper. Well, one's a perfect square, but that didn't help us simplify anything. But the next one, 2 squared is 4, 3 squared is 9, 4 squared is 16. So far, none of those divide into 75. 5 squared is 25, 6 squared is 36. 25 you say, yes it is. So I write 75 as 25 times 3, because that's what 75 is. You can think about that as 2 separate square roots, just like that. Y'all know the square root of 25 is 5. The square root of 3 cannot be simplified further unless you change it to a decimal, and that's rounding, and we're not trying to do that. So that is your simplified answer. Now when it comes to variables, you still have your properties of exponents you have to use, right? So this is the square root of 12 minus 18. But remember, we don't want to deal with negative exponents, so let's do 18 minus 12 and leave our answer in the denominator. That would be y to the 6th. Now you can handle these separately. The square root of 1 divided by the square root of y to the 6th. And square root of 1 is 1. The square root of y to the 6th. Now, when you take square roots of exponents, you're really dividing the exponents in half. So y to the 6th in half would be y to the 3rd. Okay, another way to think about it, the square root of y to the 6th is y to the 3rd times y to the 3rd, right? And then a square root of that, because there's 2 of them, and get y to the 3rd if you want to think about it that way. There's lots of ways to think about it, but that's what the lecture video is about, okay? I'm just trying to show you the fast way to do it. Now, how do we do this? 23. Well, we've got a set of parentheses with plus or minus, so we must FOIL, right? Well, absolutely. 3 times 4 is 12. 3 times negative square root of 5 is negative 3 square root of 5. So if you have a value not under a square root times a value under a square root, you can't just multiply those together and get like 15. They have to just slam together with the whole number and then the square root. I gotta have that happen again right here. I can multiply that 2 times that 4 to get plus 8, and then the square root of 5 is just a tag along, okay? And then finally, when I multiply 2 square root of 5 times negative square root of 5, I'm going to get negative. Now this 2 is like times this 1 in the front, and that'd be the square root of 25, because both of these are under a square root. You can multiply those two numbers together. All right, got a little bit of simplifying to do here. I've got 12. Now these are what we call like terms, just like when you have x terms, okay, variable terms. Well, these are radical terms, but as long as they match, you can combine the coefficients. So negative 3 and a plus 8 is plus 5. You keep that square root of 5. You don't add those together and get like square root of 10. That is not a thing. Okay, and over here, minus 2. Now the square root of 25 is 5. Now y'all, when you take a square root, you don't write it anymore. So if you're wanting to put that square root there still, you did that. You used up that square root. All right, so that gives me 12 plus 5 square root of 5 minus 10, right? 2 times 5 is 10, and 12 minus 10 is 2, and then you just 5 square root of 5, and that's your simplified answer. Now this is a solved problem, and I highly encourage you to check all of your solved problems. Well, to solve a radical, the idea is you need to get this radical on one side of the equation by itself. So that's telling me I need to add 3 and add 3 to both sides, because that 3 is not under the square root. So it's going to give me the square root of 3x plus 2 is equal to 3. Then what do? I square both sides to get rid of the, square root. The square root and the square cancel each other out. I get 3x plus 2 is equal to 9, and then I solve for x by subtracting 2 on both sides. You get 3x is equal to 7, and then divide both sides by 3. I'm trying to talk too fast. X is equal to 7/3. I circle it, but y'all, make sure you plug that in right there and make sure that's true. If I plug in 7/3, the 3's cancel. It gives me 7 plus 2, and that's under a square root. So that's the square root of 9, which is 3. 3 minus 3 is 0. The reason you need to check that is also for extraneous solutions. What if it was a negative 7/3 was our answer? Well, that would give me a negative 5 underneath here, and I can't take the square root of a negative number. So you must check those. Just like you can't have a 0 in the denominator, you're also not allowed to have a negative under a square root. All right, problem number 24. You've got the square root of 3x. Oh, we just did that, didn't we? Yeah, let's don't do it again. All right, problem number 25. Now, when I'm adding radicals, Y'all, I cannot add radicals together if they don't match. It's a like term situation. So let's simplify these radicals and then add them together. And if you're just watching me and you haven't tried this problem, and this goes for every single problem on this list, y'all don't just watch me do it. Shut me up, you do it, come back, see if you did it right. So I'm trying to break down the square root of 72. Do you know a perfect square that divides into 72? If you said 9, 9 works, but you know what? 36 divides into 72, that's bigger. So I'm going to use the biggest one because that's faster. So I have 5. Let's get my pen working here. So I have 5, stays the way it is. I'm going to rewrite the square root of 72 as 36 times 2. Plus, do you know a perfect square that divides into 50? Of course you do, 25. So it's 25 times 2. Now, if you're not good at these, I recommend highly the step of splitting up those square roots separately. So some of you, that might seem like a silly thing to do, but you need to do it, okay? By the way, my phone, I put it on silent, but the thing broke. My iPhone, I can't get that little thing on the side, and then I'm waiting on calls, so I don't want to put the volume all the way down. I do apologize profusely. So the square root of 36 is 6, so that's 5 times 6 times the square root of 2, plus 2 times 5 times the square root of 2. 5 times 6 is 30, square root of 2, plus 10, square root of 2. What do? Hey, they match, right? So it doesn't matter if the coefficients don't match. We're going to add those together. 30 plus 10 is 40, but you keep the matching square root of 2. Now, if they didn't match, we couldn't do anything else with it, but because they're both square root of 2, I can just add those together. Okay, we're just flying through this stuff, right? Solve. Now, this is called a quadratic equation. Notice that both of these, why are they quadratic? Because they have a square in them. So it doesn't matter what the variable, if it's a squared or down here x squared. The first thing that you need to do for a quadratic equation is get it equal to 0. There are certain quadratic equations that don't have to be equal to 0. Those are special cases. There's probably one in this review that I'll get to in just a minute. But the main thing is, especially if it's got 3 terms, you have to get it equal to 0. Now you have 2 ways to solve it. One is if it will really you only have one way, the quadratic formula. It works for all of them. But if a problem will factor, that's probably easier. This is multiplies to be negative 14 and adds to be 5. We can factor this thing. So this factors into a plus 7 times a minus 2, right? 7 times negative 2 is negative 14. 7 plus negative 2 is 5. Still equals 0. Well, how'd that help? Well, you set each factor separately equal to 0, which is awesome. You know why? Because anytime you multiply 2 things together and it equals 0, that means one of them has to be 0, right? That's the way 0 works. It's called the property of 0. Subtract 7 over, that gives me a is equal to negative 7. Add the 2 over, that gives me a is equal to 2. The good news about solving quadratics, you don't have to check them. Now, I highly suggest you check them because that means you can make sure you got it right, but you don't have to for extraneous solutions. Okay? Now again, 27, this is already equal to 0, thank goodness, but you know what? That 7 could have been on this side, and if it was, we'd have to subtract it over here or add it over here to get equal to 0. So make sure it's equal to 0 first. Now, this is not one of those cute ones where you just find what number multiplies to be 7 and adds to be 9. You can't do that because of that mean old 3 right there. So I have to multiply those together. I'm looking for numbers that multiply to be 21, but also add to be 9. Are there numbers that do that? 3 and 7 adds to be 10. Anything else multiply to be 21? Nope. It does not factor. Oh no. Oh no, oh no. What does that mean we do? Your best friend, the quadratic formula. You know it. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. There's a song for it. You probably know it. I'm not singing it. Okay. Only in my head, right? So what is a? What is b? What is c? A is always the coefficient of the x squared term. So a is 3. B is always the coefficient of the x. So B is 9. If you don't have an x term, then B is 0. Okay? C is always the constant. If you don't have a constant, what is a constant? A term without an x value or variable. Then C would be 0. But we got everybody right here. So it's x is equal to negative 9 plus or minus the square root of 9 squared minus 4 times A is 3. C is 7. And this is all divided by 2 times 3. 2A, right? Accidentally wrote down C, so 2A. Now, you simplify under that square root first. So it's plus or minus the square root of 9 squared is 81. So that's going to be 81 minus 4 times 3 is 21 times 7. Y'all, don't judge me. I'm going to pull out my calculator because I don't really want to do this in my head. So again, I'm doing 9 squared minus, actually, I wrote 9 squared down. So I'm just going to do 4 times 3 times 7. And that gives me 84. And that's all divided by 6. That's negative 9 plus the square root of 81 minus 84 is negative 3. What? What? That's the square root of a negative number. We can't do that. That's bad news, right? Now, I'll go ahead and warn you. When you take Math 112, you're going to take the square root of negative numbers and get imaginaries. But right now, you're lucky you get to stop right there and say this guy is not real. And really, it was going to be 2 answers, but neither one of them are real because you have the square root of a negative number.